everyone. Today we are going to be graphing linear inequalities. So we're going to take all the skills that we learned about graphing regular linear equations and we're going to apply that to inequalities. So let's take a look. Okay, so first let's define what a linear inequality is. It's an inequality which involves a linear function. A linear inequality contains one of the symbols of inequality. So these should all look familiar. So we have the less than symbol, the greater than symbol, the less than or equal to symbol, and notice how it's different from the less than symbol because it has this line underneath. Think of that as half of an equal sign. So it's less than or equal to, and then greater than or equal to. Okay, if you can write the word less with the symbol, that can help you remember which one is less and which one is greater than. Because if we were to do this, that doesn't look like the word less, so this is the greater than symbol. So we don't want that. So here's an example of a linear inequality. So we have y is greater than 2x plus 1, and this is what the graph would look like. So this is what we're going to talk about today. You're going to notice it's different from a linear equation because we have a dashed line. We're not always going to have dashed lines, but in some cases we will, and we'll talk about that. And there's also a shaded region. This we're always going to have. It's not always going to look exactly like this, but there is always going to be one side of the line that is shaded. So let's look into how we graph these. Before we graph them, let's actually talk about what solutions to these linear inequalities are and where they are on the graph. So a solution to the linear inequality can be found in the shaded region, and a solution to an inequality is any point that would make the inequality true. It can only be found on the line if the line is solid, and that's very important. That's why it's in bold and in all caps. So it can be found on the line only if the line is solid. Solutions cannot be found on a dotted line. So for example, we have this point here. It's in the shaded region, so it's a solution. We have this point here. It's not in the shaded region, so it's not a solution. Then we have this point here. It's on the dotted line, so it is not a solution. If this was a solid line, this would be a solution. But because it's a dotted dashed line, this is not a solution. Okay, so please remember that. That's very important. These points are the points where if we plug them into our linear inequality, the inequality would not be true. Okay, so now let's get to graphing these. So here we have our coordinate plane, and we have this inequality, y is greater than 3x minus 2. So the first thing that we're going to do here is we're going to graph points using the slope and the y-intercept, what we're used to, but I'm not going to connect the points yet. So first I'm going to identify my slope, and here we see it's 3. So m is 3. I'm going to put it over 1 because we want to write the slope as a fraction, and our y-intercept is negative 2, and that's where we start. So this should look very, very familiar. So we have negative 2. I'm going to put a point there. And then my slope is positive, so that means I'm going to go up 3 over 1. 1, 2, 3 over 1. And I'm going to continue that and put as many points as I physically can. And it's even more important now than it was before to make as many points as you can. Okay. So I have all these points, and now we have to decide how we're going to connect that. So normally we would just draw a regular straight old line and be done, but this is an inequality, so it's a little different. So to determine whether the line is dashed or solid, we're going to look at our inequality symbol. So here we have a greater than symbol. So please note that. So if this symbol is a less than or equal to, greater than or equal to, so if it has this little line underneath, it's going to be a solid line, lines that we're used to. If it does not have that symbol underneath, if it's just less than or greater than, not equal to, it's going to be a dashed line, just like we saw in the example. So here we see that this is this symbol here. So it's going to be a dashed line. So I'm going to connect these points with a dashed line. So it's going to look just like this. So I'm leaving spaces in between. Doesn't need to be perfect, but you need to be able to see those spaces so it doesn't get confused with a solid line. Okay? So we're almost there, but in our example, we saw a shaded region, and we need to decide where we're going to shade. Okay, so to find out where to shade the line, we're going to choose a test point, and it can be any point not on the line. If we pick a test point on the line, it's not going to give us any information because we need to know where we need to shade on one side or the other side of the line. So if the point makes the inequality true, we're going to shade that side of the line that contains that test point. If it makes it false, we're going to shade the other side of the line that does not contain that test point. So you'll see what I mean when we do an example. So I'm going to pick, so normally I would pick 0, 0, which is right here. That's a little too close to the line for me. I want to pick points that are further away. So I'm going to pick a point just in this open area over here. Okay, so I'm going to pick this point here. -4, 3. Okay, so I'm going to just write that over here, -4, 3. You can pick any test point as long as it's not on the line. Okay, so now I'm going to take these values and I'm going to plug it into our inequality. So remember, this is x, this is y. I'm going to just rewrite our inequality down here. And I'm going to substitute the x and the y values into our inequality. So instead of writing y, I'm going to write 3 because that's what our y value is greater than 3. Instead of writing x, I'm going to write parentheses -4 because we're multiplying here, -2. Now I'm going to simplify what's on this side. 3 times -4 is -12 minus 2. And then 3 is greater than -12 minus 2 is -14. So here we have an inequality that says 3 is greater than -14. And we have to think, okay, is this true? Is 3 greater than -14? It's a positive number. All positive numbers are always bigger, greater than negative numbers. So this is true. So I'm going to write true. So that's this scenario here. So if the point makes the inequality true, we're going to shade the side of the line that contains that point. So we have this side of the line here, and we have this side, and let me just use the pointer that's a little more, okay. We have this side of the line here, and this side of the line here. We got to decide which one to shade. This point made the inequality true, so we're going to shade the side that contains this point. So we're going to shade this entire side of the line. And it's going to look just like this. Just like this, all the way down. Don't stop at any axes. We're not looking at the axes, we're just looking at the line that we graphed. Now, if I picked a point on this side of the line and we plugged it into the inequality, it would be false. We would end up with something like 2 is greater than 10. We know that that's not true. So if it's true, you shade the side of that point. If it's not true, you shade the other side that does not contain that point. Okay, so now we're going to take a look at a question like this on Delta Math. Okay, so we have the example y is less than or equal to 3 over 4x minus 4. So we want to graph this linear inequality on the graph below. So the first thing we're going to do is identify our slope and our y-intercept. So our slope is 3 over 4, always that number in front of x. It's already a fraction, so I don't need to add a denominator here. And our y-intercept is -4. So remember, we're going to start here at our y-intercept. So I'm going to put a point at -4. And then I'm going to go up 3 to the right 4. So up 1, 2, 3 over 1, 2, 3, 4. Okay. So our line is graphed, and we need to decide whether this is going to be dashed or solid. So you can change it just by clicking this. Now, hopefully you remember that if we have a less than, because our inequality symbol is less than or equal to, that means this is going to be a solid line. It has that or equal to. So I'm not going to change the line here, but if this did not have that symbol underneath it, then I would change it to a dashed line. All right, so we're going to keep it solid. And then we have to decide where we're going to shade the line. Here we see it below or above, but we have to decide where that is. We can't just take a guess here. So I'm going to erase the slope and the y-intercept, and we're going to pick our test point to see where we would do this. Okay, so my favorite test point is 0, 0. The number 0 is so easy to work with. So if you can use that as a test point, please do that. Just make sure that test point, as I've said before, is not on the line, because then you're not going to get any good information here. So this is our x, this is our y. I'm going to just rewrite this inequality here. I'm just rewriting it. And then I'm going to plug in a 0 wherever we see a y and we see an x, because both those values are 0. So we have 0 is less than or equal to 3 over 4 times 0 minus 4. Let me just scroll down a bit. Okay, so 3 over 4 times 0 is just 0. So I'm going to bring everything else down. And then 0 minus 4 is equal to negative 4. So now we have this inequality. It says 0 is less than or equal to negative 4. Hopefully you remember that that's not true. 0 is always greater than every negative number. So this is false, which is different than what we saw in the original demonstration on the PowerPoint. We had a point that was true. In this case, we have a point that was false. So on our graph, the point 0, 0 is right here. So we want to make sure that the side that does not contain this point is shaded, because it is false. If this was true, we would shade this side because it would contain this point. But because this is false, we want to shade the other side. So I'm going to leave the shading just as it is, because it is shaded on the other side of this test point, because this was false, okay? If you need to change it, you can always click change shade. So this would be if it was true, but it's false, so we're going to shade the other side. Make sure you submit your answer. Make sure you double check for your dotted lines and where your shading should be. But make sure that you use that test point not on the line.